Hi, everyone. So, have you ever wondered how to be more confident about improving your application and application structure? And by this, benefit from a more reliable runtime and also have a clearer separation between your application logic and application topology. Because we're all in the business of innovation. So we want to experiment, we want to listen, and we want to iterate based on the feedback as quickly as possible. And to do this most effectively and improve also our developer productivity, we should focus our efforts on the business value and improving it, and on the other hand, rely as much as possible on managed service. But the question then is, how can you transition safely and confident from one to the other? So, in case you're wondering, hi, I'm Luis. I'm working as a solutions architect for AWS, and I'm mostly working with digital native businesses here across Germany. I fell in love with coding many years ago, and especially like the approaches from extreme programming, such as test-driven development or behavior-driven development, so TDD or BDD. And especially how to leverage refactoring to improve your application and application structure. Since then, I try to automate pretty much everything I do. And especially in a serverless world, automation is really key. But automation isn't a new idea. So Ford revolutionized the automotive industry a lot of years ago by building the Model Ts on an assembly line. It was much faster than anyone can do it by hand. So the key driver was efficiency. So automating things was faster and required fewer workers than doing it manually. That was really great, but it was also 100 years ago. In the cloud, it's not just about improving the efficiency. You can have much more benefits. For one, automation speeds you up. And that's a big deal because your pace of innovation goes up. But of course, going quick isn't any good if it's not repeatable and if you're not able to have the thousands deployment run exactly the same way as your 999 times before. And that, in the end, gives teams confidence, an often overlooked benefit. So a lack of confidence can slow you down and leads to bad habits like not fixing things. So also, it's not that much fun, so maybe let's focus more on that part. Also, the magic of speeding up isn't just about going faster, it changes the way you work, like making your code and your infrastructure disposable. Why should I spend time patching up a server if I can get rid of it and provision it in a matter of minutes or even seconds? And last, automated processes are transparent. So you can see how long each step took, what your failure rate is, and where you need to improve. So in summary, automation in the cloud isn't just about improving the efficiency, but it's about working differently. And with playing such a critical role, you can almost go as far as saying if you subtract the automation part of the cloud, it's just another data center. So don't get me wrong, we have nice data centers, but I haven't met a customer who's solely here for the data center part. It's more about other parts. And with the automation playing such a critical role, let's have a closer look and try to decompose how the automation stack looks like. So first of all, you want to provision resources. So in our trivial example here, we have 2 virtual machines, a load balancer, and maybe a gateway. But just the resources on their own don't do much. You have to deploy something on top, a concrete workload that does this. It's better, but still these parts are disconnected. So we have to enter the next step, the composition part. How are the things connected to each other? And in the end, you also might have different configurations. So, for example, you have a primary server and secondary servers, or your backends talk to different databases and therefore need different configuration. So, this architecture overview should help us to understand the different aspects that come together when we say automation. And of course, we want to describe this automation in a language. It turns out we have a couple of choices. So first of all, document-oriented. You might have seen that a couple of times. So you have things like JSON or YAML that are used by tools such as CloudFormation or Terraform. They are quite popular, but also a bit limited in the capabilities you can have. So, for example, you can't have loops, conditions, or list comprehensions out of the box. Functional languages, on the other hand, such as here with Pulumi, with F#, have pretty powerful tools such as map, reduce, list comprehensions. You can even carry your functions. But in the end, we need to remember that we also have an application to build. And we might not want to have a more complex and more sophisticated automation language than our application language. So we find that most of our application code still resides in object-oriented languages. And that makes it also a good choice for our automation code. Because then you can rightly claim that you write infrastructure as actual code for your automation part. And there we enter the AWS CDK. So who of you is already using the AWS CDK? Can you raise a hand? All right, good. So for the rest of you, the AWS CDK, the Cloud Development Kit, allows you to write infrastructure as actual code with popular object-oriented languages. So let's build a quick application, a simple containerized web application. The first thing you would do is laying out the networking foundation with Visual Private Cloud, a VPC. Next, we would define a container cluster inside this VPC, and that's also a one-liner. So you can see that defining your infrastructure as code here gives you the flexibility of an object-oriented language because you can use methods, you can use classes, and object-oriented references. Sorry about that. Good. Now let's set up the next part. We want to have the load-balanced web application. As this is a common pattern, we can use a network load-balanced Fargate service. This will provision the serverless container runtime, so Fargate, in that case, to handle your application, and based on the provided application image, as you can see here. So the CDK gives you here the necessary abstraction of well-defined patterns that you can use, and they have sane defaults. And of course, you can use them and abstract your own patterns out of that. And finally, let's extend the discoverability of our application by adding a domain name. So just like a standard library, it comes with CDK tools like inline documentation or autocomplete. So that's all the benefits you can have if you're leveraging AWS CDK. In this case, that's all in TypeScript, but it comes also with 5 other different languages that you can use here. And the power of this example is that these couple lines of code translate actually to 450 lines of CloudFormation code. And it's, of course, much more readable in that case. And with tools such as the AWS CDK, you're not only being able to define your infrastructure as actual code. If you think about serverless application, things as deployment, the composition, and the configuration part are the main drivers for leveraging these kind of automation tools. So you can say this is much more than infrastructure as actual code. But let's come back to serverless and serverless automation and how it maps to the automation stack that we've seen before. The provisioning part is taken care of for you, and the deployment can be as simple as putting a zip file in a bucket. So the element that's becoming most prominent for serverless applications is the composition part. So composition, how are the things wired together? And this comes with things like the granularity, so how big or how small are my components? How are they wired together in terms of synchronous or asynchronous communication? And in the end, it often uses managed service interactions, such as the Amazon SQS or Amazon SNS service or EventBridge. And serverless automation in an object-oriented language blurs the line between the application code on the one side and the automation code on the other. And that's a good thing, because then you can describe your application topology in a fully fledged object-oriented language, and that makes it easier because it allows you to maximize the use of managed service in that case. And we will see a couple of examples there. And having both of these in potentially the same programming language gives us the basis for refactoring. Because having the application code and the automation code side by side, we can ask, how do they two relate to each other? And can I refactor functionality from one side to the other? So let's quickly define refactoring for those of you who are not aware. So Martin Fowler defined it once as refactoring is a control technique to improve your design of the application, but the most important part, it should preserve the behavior. And refactoring as a technique is mostly used in the TDD or BDD community in the form of a red-green refactor cycle. So first of all, you try to implement a test that verifies that a certain behavior is there in the application. And of course, you have to execute the test first, because don't assume anything about your code, verify it. So you go then from the red cycle to implement this kind of behavior and run it against the tests to make sure that the behavior is now there. And after that, you have the confidence to say, can I improve my application based on the things that I've built? And this is the third step in the refactoring cycle. So let's take a look at a concrete example. So in this case, we have a very simple Lambda function. So you can see we have the results that are computed, and there might be some business logic implemented behind that. And afterwards, we want to send this as an event to SQS, so the simple queuing service. Why would you want to refactor this code? Because it works. What can we improve here? You might see that the topology is right now hidden inside environment variables that are passed into your Lambda function. And also the application logic and the application topology is residing in the same application. And with this, you have to grant the IAM permissions for the Lambda function, configure retry behavior and error handling. But also, if you want to change the way you integrate the service, you would have to change the application. So let's say we are implementing an order service, and the order service emits an event. And so far, there was only a payment service that was interested in that kind of event. But if you add over time maybe a fulfillment or a shipping service or loyalty service, that would change the way you integrate those. And to do the changes in the integration part here, you would have to go back into your application code to change the integration. So what can we improve here? By clearly separating the business logic and the topology. So Lambda already has the perfect feature. It's called Lambda destination. It helps you, especially for asynchronous invocations, to specify what should happen with the result. And this provides you with the necessary visibility and routes the execution result. So you also have to take less care about retry or error handling in this case. And this can simplify your event-driven application and reduce by this the code complexity. Also, it helps you to send the results not only to SQS, but to SNS with less code changes in that case. And also, the SDK doesn't have to be bundled into your application. And there are a couple of motivations for serverless refactorings in general. So first of all, you can better leverage cloud platform capabilities, such in the previous example, using the native capabilities. This reduces the lines of code you have to manage, but also the retry, the failure behavior, which can become quite complex also to fully test it. And by this, shifting the responsibilities from your side to AWS and benefit from the scaling and the robustness of the platform. Also, the AWS capabilities are continuously evolving and improving. So what you had to build before in your own application might now be available as part of the platform. So refactoring your code from the application side to the automation side is a good way to maintain the same capabilities while reducing your maintenance efforts. But sometimes also the inverse might be true. So it could be the case that your application needs have outgrown the current capabilities of a service, and then you have to extract them and implement it in your own application. Refactoring can also improve your runtime characteristics, like latency, availability issues, and there you could also leverage the cloud. And last but not least, refactoring can also save you costs because you maybe reduce the number of runtime components and by this decreasing the cost. And we will see an example for this in a second. Based on these 5 motivations, Gregor Hoppe and also Sindhu Pillai collected a couple of serverless refactorings and built up a catalog. So let's take a quick look how this looks like. So for leveraging the platform capabilities, you can not only use the Lambda destination, as we have seen before, but also use, for example, the filtering capabilities of EventBridge instead of custom code in your consumer application. And this could also reduce your cost because, of course, if your consumer application is not called at all to filter out an event that he is not interested in, that makes it easier and more cost efficient. Alternatively, instead of writing code to notify the successful persistence of domain events, you can also leverage DynamoDB streams plus EventBridge pipes, and we will see this as an example in a second. Also, for evolving the AWS capabilities, we can leverage the ever-growing service integrations from especially step functions without the need for an additional Lambda function. So, such as the direct service call to recognition, our image recognition service, which we will also see in a minute, and by this reducing the overall cost, or direct database access with the DynamoDB get task functionality. Also, the application needs evolve. As mentioned before, for example, if you have a highly sophisticated pattern matching that you can't rebuild in EventBridge, for example, you can extract this to your own Lambda function instead. And last but not least, if you want to improve your runtime characteristics, you could go, for instance, by replacing the polling with wait for callback and step functions, or convert a choreography into orchestration. But as with every architectural decision, a potential refactoring comes with its own trade-off, and we have to be aware of those. So we don't want to lose the business functionality, but we might introduce side effects by refactoring to platform capabilities. So it's important to be aware of those side effects and rationalize about the trade-offs. And developing serverless solution means building a distributed system in general. So we have to be aware that evolving the application topology can impact your latency or your cost profile. And sometimes these kind of refactorings drive behavior to become asynchronous. So let's take another look at our first example, so extracting the sent message directly. By introducing the Lambda destination instead of using the direct service calls, does the behavior change? Does it introduce any side effects? To understand the impact of this refactoring, we have to be aware how Lambda functions can be invoked. It can be either synchronous or asynchronous. And Lambda destination will trigger only if your Lambda function is asynchronously invoked. Also, we should take a look how the resulting message that is sent to SQS should look like. Because you can see in case of leveraging the Lambda destination, it's bundled in an event envelope and contains additional metadata. But of course, the interesting piece, the payload, is still there. And lastly, the invocation of SQS occurs at the end of the function execution. So if this has been the case before, then of course there's no change. But if you have to compute something intensive after you send the event, then this might not work. What we rather see in this case, if you have to send the event before and then have the heavy computation, is to rather extract this into two functionalities, into two functions potentially, and then orchestrate them instead. So we can see, even though the behavior of the application is mostly preserved, the consumer would have to change to adapt to this, but still you can benefit from the runtime environment. But let's take a look at a second example. In this case, the goal of this application is to have quality control in a food production line. So to orchestrate this multi-step approach, you can see that we are using step functions in that case, so our serverless workflow engine. And we will use recognition to do the image recognition part. And then we check, have you seen either a pizza or does the number of pepperonis still fit? How can this be improved is then the question. As you can see, we have a simple Lambda function that calls recognition in that case. And we might leverage here, in this case, rather the direct service integration of step functions. So we have right now over 11,000 API actions for over 250 AWS services that can be directly integrated. And by using that, we can get rid of the Lambda function, so another component you would have to manage and maintain. And by this, save the costs and improve also the performance. Also, we shouldn't forget about the capabilities of step functions regarding intrinsic functions. So these are inline functionality that you can use that you don't have to extract to your own Lambda function in that case. How does the code look like? We can see that the application code is here just for the service integration. And we can get rid of the Lambda and don't have to worry here about maintaining the code, handling errors or retries, and instead have a direct service call, specify the parameters and the IAM policy, as you can see here. So no application code to maintain, and the topology is solely defined in the automation side. So every time you see that you're leveraging Lambda just for connecting two services, that can be a good indicator for a refactoring. Because we want to use Lambda for changing, for doing transformation work and not transportation work. And by this, we can also decrease our costs. And let's take a look at a last example. As mentioned before, sometimes we want to persist a domain event or domain change. In the serverless world, you might leverage DynamoDB, and afterwards notify other consumers, hey, an event has changed. To do this, you can use DynamoDB table and EventBridge directly, and this gives you several advantages. It gives the Lambda function and your application code with this more control of the overall event and event structure. It is also simple and minimizes the number of runtime components. And it decouples the receivers from the senders, and you don't conflict with any internal data structure representation of the producer. But the more important question is, what could go wrong with this approach? Because the application dependencies are currently bundled into the Lambda function itself. So every reference to the event bridge might be parsed in via environment variable. And you want to, if you want to change that, you have to dive deep into the application code to make changes if you want to add a field or something. Also, another issue that you might have is that the writing to the database and emitting the event are not in the same transactional scope. So if you have a failed database insert, you might want to either retry or send an exception back to the client. But if the write was successful, but the publishing of the event is not, then you might have a bigger problem and have to think more, how should I handle these kind of environment? And there might be an easier option because DynamoDB Streams has the capability to send out change data capture, which you can then use to transform it in the end. So, who of you is already using the EventBridge pipes? I just see a single hand. Who's using the EventBridge pipes right now? All right, okay, cool. Then EventBridge pipe is a new feature that was introduced in reInvent 2022. And it helps you to not only publish events to various different targets, but it also comes with capabilities of doing message transformation and filtering. And this can be used then to read from the DynamoDB stream transform the event because it contains some additional metadata from DynamoDB, and then put it to EventBridge. And as you can see, in this case, EventBridge pipes becomes part of the application side and not the integration part, which is also definitely important to consider. But you might want to ask, does my cloud bill now go up? It may be, because EventBridge pipe costs around 40 to 50 cents per million events that you will send. But of course, also your Lambda function gets smaller and by this faster. So this reduces the cost overall and offsets a fair portion of the overall cost. But you would also have to implement the retry and error handling in this case. And we have to be aware that for a single developer hour, you can send almost 250 million events. So you have to consider that for a single bug that you might have in specifying the wrong transactional scoping. It might be more cost efficient here to leverage these kind of functionality. And if you want to have a more deep dive into that, Gregor Hoppe put this on the architect elevator. You will get a QR code in the end, so no need to type that. So let's take a look how the implementation looks like. So you can see that the application code side, of course, got reduced. There's also no need of transactional handling here, and instead you can leverage the retry mechanisms that are built into the platform. Also, you don't have any kind of dependency to EventBridge in that case, and this way you have a smaller footprint and more maintainable solution. But you have to be aware that this might impact your overall latency. And to come back to our original statement from the beginning. So in the cloud, you don't just do things and later automate this to reduce the overall toil. Automation is an integral part of application design because it impacts your architecture choices and makes them more explicit. And now the important question might be, but how should I integrate this into my development flow? When and how often should I actually refactor? The first piece of advice comes from Martin Fowler and also the whole continuous delivery practice. If it hurts, do it more often and bring the pain forward. That's especially true for the tasks that happen less often, so time between actions, such as doing testing, deployment, or refactorings. To get the most out of refactorings, make sure that your test cases verify your aspired behavior. And the biggest challenge for doing this is, sorry, and that's one of the biggest challenge that you might have here. But on the other hand, if you already perform a high rate of deployments and have a great confidence in your overall test suite, of course, the inverse is then also true, because refactoring then becomes a smaller thing. So you can almost say that continuous refactoring in your code is almost a maturity assessment of your deployment and automation suite. And of course, refactoring should be already part of your software delivery in general, but there are some things that you should be always aware of. If refactoring is painful, that might be because your test coverage is not high enough or you lack certain deployment automation. So you should go and fix those first so you can release your software more often and more confident, and by this also refactoring more regularly. One of the other important steps in the whole red-green refactor cycle is to improve your code. and not just the application logic, but also the application topology. With a constantly evolving serverless ecosystem, as we mentioned before, there's a good chance that something you have implemented so far might be now part of the platform capabilities. So you want to maybe check for this. But you should also be aware of the additional functionality, because that can increase your application's complexity. Therefore, have only moderate refactorings to maintain your development velocity. Sheen Brizzles put it best. So he's part of the Lego group and one of our AWS serverless heroes. And he recently wrote a blog post about serverless teams should embrace continuous refactorings. And there are some tips that we can highlight there from here. First of all, we should turn refactorings into the needs of the business. So instead of saying we want to improve the latency of our application, we should convert it into a more business highlighting metrics such as customer satisfaction. Also, he recommends to have a refactoring sprint at least once a season. Some of the teams might even want to do it more often. And to do this effectively, you should always keep a refactoring backlog, because when the meetings around planning, OKR seasons, and whatnot comes up, then you can look back into your backlog and integrate one or two tasks maybe over there. And last, refactoring can be also a technology motivator, because you're playing around with new services, new patterns, or leverage different capabilities. And these in itself can be more fun to work with and be an attractor also to having more talent. And you can find the whole blog post in this link, but again, I will present you the QR code in the end as well. As always, you might also have some common counter-arguments that you have to overcome when you establish refactoring in this case. So first of all, a few lines of code might not do that much harm until the library that you're using goes out of service or support, or they have some hidden bugs, or someone removes it, so they're not sure why it was needed in the first place. So treat your code, especially application code, as a liability and not an asset. Also, you should not fall for local optimization. When you refactor, take a look at larger application scope and not solely inside one specific application, to really make sure that you benefit from the overall system. And last, you might be tempted to think that doing everything in application code reduces the login. You came to the cloud to benefit from the platform capabilities, so you might want to use that and focus your efforts, as said in the beginning, rather on business capabilities. So I hope this session has shown you how refactoring can be applied to serverless and serverless application by replacing application code with automation code. That way, you can better utilize platform capabilities and become even more serverless native, you can say. And as mentioned before, we have a couple of resources. So if you scan the QR code, it will take you to serverless land, where there is some detailed information around refactoring to serverless, and you can find a couple of those patterns, and we will always update them and extend the overall collection. Also, I mentioned the blog post of Sheen. So you can scan the QR code for his Medium blog post. It's a really interesting read. And last but not least, I mentioned also the blog post of Gregor Hoppe around will my cloud bill go up when I have now everything loosely coupled. He comes with much more details on the things, and in general, the Architect Elevator is a good resource for information. I'm also happy to connect on social media, or if you have questions, you can find me over there in the next couple of minutes. Also, please take some seconds to complete a session survey in the mobile app. And with this, now go build with refactoring to serverless. So thanks for your attention.